record. Okay, I guess I'll probably just do question 2 just for completion. So a lot of you started out on question 2. This is the kind of question that you have to be able to do for this particular topic. If calculation is not your strength, then you have to make sure that you can make it your strength. Here, they have asked you on magnesium oxide, they've asked you on magnesium chloride, they've asked you on water. So what we know is this is water, this is magnesium chloride, and then this is MgO. So we got nothing to do with HCl, so we don't need to find anything with HCl. Relative molecular mass, or MR, is essentially for 1 unit, for 1 formula unit. So when you have 2 or 3 in front, it's not considered as MR. This is only for 1 formula unit when it's 1 of it. Never for 2, never for 3, because you have to multiply. So the MR for MgO is going to be 24 times 1, because there's 1 magnesium, plus 16 times 1, that's going to give you 40. MgCl2 is going to be 24 plus 35.5 multiplied by 2. You should be able to do this very quickly. Therefore, make sure you know how to press your calculator. So the MR for water is going to be 2 times 1 because there's 2 hydrogens, and 16 times 1 because there's 1 oxygen. So 2 times 1 plus 16 times 1 is 18. So altogether, we can see the proportion is that is from the MR. So what we say is 40 grams of it will give us, there's 1 of it. So they will give us just 95 grams, and there's just 1 water. So they will just give us 18 grams of it. So magnesium oxide is to the magnesium chloride, 1 mole, 1:1. So what we are saying is 40 grams of magnesium oxide will give us 95 grams of MgCl2. So therefore, when you have 95 grams of MgCl2, we are looking at what is this number here. So very coincidentally, you can see that these things are exactly the same. So therefore, this must be exactly the same. So what we're saying is we'll have 40 grams of magnesium oxide. Now we can also see that, where is it at? MgCl2 and also water. So we're looking at MgCl2 and water. So essentially, it's not really an error. It's really both of them as product. So 95 grams of it, because there's only 1 formula unit of it. So it's 95 without having to multiply by anything. And there's 18 grams of water that is produced together with 95 grams of magnesium chloride. So now when you have 95 grams of magnesium chloride, well, you know, it's going to be the same thing again, because this is from the balance equations based on the MR. This is based on the question. Therefore, since these are the same, this must be the exact same thing. That's why you can get the free 2 marks there. The very last bit is the slightly tricky thing, because now you want the magnesium oxide, which is MgO, and you want the magnesium chloride, which is MgCl2. So if I relate MgO and MgCl2 again, so there's 40 grams to 95 grams just now. So unless you know how to calculate your relative molecular mass or your MR, you will have problem with this kind of question every single time. Here, this is slightly tricky because it's no longer the same number. It's 4.75 grams. So what we're saying is this is X. So 40 grams of MgO give you 95 grams of MgCl2. So what we do is we can cross multiply. When you do cross multiply means on the opposite side. So you have 40 gram is just a unit. So I don't want to show the gram now. So just the number times the number, and then the number times the number, which is an unknown here. So as you know from your mathematics, you just move the 95 to the bottom, and then you just press your calculator now, and you will get X equal to 2. The unit is gram because all of this is in gram. So this has to be in gram. So that has to be 2 grams of magnesium oxide. Okay. Now the next thing is very last thing. This is on reactions of acid. So as you know, acid can react with base. That is called neutralization. Acid plus base give you salt and water. Acid can react with metal. Acid can react with metal to give you metal salt and also hydrogen gas. So metal salt. Oops, I don't want that. Acid plus base plus metal. So perhaps I can move this on the other side a little bit. Okay, so these are just recap of your reactions. Acid plus base give you metal salt. As you know, you get chloride salt from hydrochloric acid, you get sulfate salt from sulfuric acid, and you get nitrate salt from nitric acid. Okay, so acid plus metal will give you a metal salt, and also hydrogen gas. Hydrogen gas is H2, diatomic. Neutralization also give you water. Last but not least, you also know that acid reacts with something called metal carbonate. Carbonate ions. Carbonate ions is basically CO3 2 minus, and they will give you metal salt. And they'll give you CO2, carbon dioxide gas, and H2O. Carbon dioxide is being asked in the other questions. We can test it with lime water. It will turn lime water milky, cloudy. Anyway, so it said two other substances that will react with acid to give you the salt. This is a magnesium oxide. This is an oxide of metal. Oxide of metal is going to be something you call basic oxide. You learn this as part of periodic table. Basic oxide, oxide of the group 1 and group 2 metal. So you already talk about neutralization because you're reacting with a basic oxide. So we just need to talk about metal and metal carbonate. So there's just magnesium as a metal reacting with hydrochloric acid will give us the salt and hydrogen gas. And last but not least, it's going to be magnesium carbonate reacting with the hydrochloric acid to give us the salt, which is magnesium chloride, CO2, as well as H2O. What I'll do is I will not go through question 3, question 4, and question 5 because they are available as the tutorial video. I'll go straight into question 6, which are not available as the tutorial video that I've uploaded onto the playlist. So hopefully they'll be as useful for you. Okay, with this kind of work, it's math, it's doing. You will not get any better. You will not learn anything by listening. You need to learn the trick and do it yourself. You cannot remember one day and forget the other day because you know this kind of question would definitely come out. And when they come out, they're usually 5 marks or well, maybe 4 or 5 marks out of the chemistry component. Question 6, so this is calculate the relative molecular mass. So you must be able to do this in, well, 2 minutes. Ammonium chloride, what does NH4Cl means? It means there is 1 time nitrogen, there is 4 time hydrogen, and there is 1 time Cl. Each of these, nitrogen has a mass of 14. So 14 times 1 plus hydrogen, there are 4 hydrogen. Each hydrogen has a mass of 1, and there are 4 hydrogen atoms. And then I have 35.5 where I have 1 chlorine. So press your calculator and make sure you press correctly because one mistake here would mean you mess up everything. Sodium hydroxide, Na plus OH minus, sodium hydroxide, hydroxide ions, remember is OH minus, that is your pH greater than 7, that is called hydroxide ions. It is a base, it is an alkali. So what happened there is you have 1 sodium, 1 oxygen, and 1 hydrogen. So it's just 23 times 1 plus 16 times 1 plus 1 times 1. You should be able to press your calculator very quickly and you get 40. Now, these are important steps. If you get this wrong, you will mess up this thing here. So be very careful, yeah? The MR of ammonia is 17 because ammonia is NH3. So 1 nitrogen is 14, 3 times 1 for the hydrogen. So 14 plus 3 times 1 is 17. Now, what do we know? We want to talk about ammonia. We want to talk about sodium hydroxide. So we look at sodium hydroxide, we look at ammonia, okay? So sodium hydroxide, 1 of it, give me 1 of ammonia. They don't put a number in front, that means it's 1 and 1, just like that. And then what happened is I look at the MR. Sodium hydroxide is 40 and I have 1 formula unit. So I put down 40 there. If I have 2 formula units, I have to multiply by 2 because this is for 1 unit. This is for 1 unit. If this is 2, I have to multiply by 2. If this is 3, I have to multiply by 3. This is also 1 and it's already given, 17. So there's 40 grams of NaOH will give me 17 grams of NH3. So what do I know? 34 grams of ammonia. So I want 34 grams of ammonia. This is sodium hydroxide. This is ammonia. So ammonia, 34 grams is on this side. And what do I know? I have this one as X. So, you know, you cross multiply the numbers. So the opposite side, 40 times 34, just the number, 17 times X. So X equal to 40 times 34 over 17, x equal to, so you must know your calculator very, very well. Yeah? Okay, so that is 80 gram. And then next up, you have the same problem, but you have 0.85 gram of ammonia. So what I'll do is I will copy the exact same thing, but I don't want X anymore because I want to show a different working. If I use X, it means it's the same thing. So it's the same ratio, NaOH and NH3, but I want 0.85 gram now. So 0.85 gram, I want Y. So something else that's different. The same strategy, cross multiply there, and that give you Y. So if you can do your math, you should have no problem with this. The problem is you calculated it incorrectly, the MR, and then you couldn't do the math correctly. That gives you 2 gram there. So that's 2 gram. All right, next up, state an industrial use of ammonia. So ammonia is used to make fertilizer on a large scale. So we're talking about millions and millions of tons for agriculture all around the world. So, you know, the fertilizer itself is like ammonium nitrate. So this is example of a salt. So ammonium nitrate is a salt that you get by reacting ammonia and also nitric acid. When you have ammonia and also nitric acid, you will get the salt because it's a neutralization reaction. You get ammonium nitrate. So obviously, if I use sulfuric acid, I'll get ammonium sulfate. If I use hydrochloric acid, I'll get ammonium chloride. Okay, so I don't have much time left. I want to move on to the next bit. This is just the outer shell electrons. So, you know, nitrogen is in 2,5. This is your year 9 bonding topic. Hydrogen is just valency 1. So we're talking about valency. How many electrons? You know about these from your year 9 bonding topic. How many electrons to get to fully fill outer shell? This is the objective of covalent bonding. Okay, so 5 electrons there, 1 electron there. You just need 1 more because first shell can only have 2 electrons. Second shell can have up to 8 electrons. You do the cross multiply, where you do the crisscross. This is basically telling you how many. Obviously, you know from the diagram that you have 3 hydrogens. And there's a reason why you have a covalent bond, 1 electron from hydrogen, 1 electron from nitrogen. So dot cross, 1 covalent bond is 2 shared electrons. So I can draw using a line. 1 covalent bond is 2 electrons. Nitrogen has 5 electrons in the outer shell. I've only used 3 for covalent bonding. I still have 2 more. If you count across, originally there are 5. Now I share 3 more dots, and this diagram is complete only because I've shown the remaining one in the outer shell. It's 2 marks because this is the one that a lot of students always forget to count. Counting is part of the primary school mathematics. Moving on to question 7. So like I said, I don't have much time, so I'll rush out a little bit. Calculate the relative molecular mass of carbon dioxide. One of the most common mistakes the students make here is they see the 2 in front, then they calculate for 2 CO2. MR, this is MR. MR is for 1 formula unit, 1 formula unit, never for 2, never for 3 or any more. It's always for 1 formula unit. So we are just looking at CO2. We're not looking at the number in front at all. Be very, very careful there. So calculate. There is 1 carbon and there is 2 oxygen. So 12 times 1 for the 1 carbon, and then 16 times 2 for the 2 oxygen. Press your calculator. And like I said, you must be able to know your calculator very well. If you yourself have used a calculator for 3 years and you still press it incorrectly, you still don't know where the buttons are, something is very wrong, okay, after 3 years. Now complete the following sentences. We are talking about ethene. Ethene is an alkene. An alkene is going to be the CnH2 end, which is the C2H4. So we're looking at carbon dioxide, we're looking at water. So there's carbon dioxide and there's water. First of all, I'll write in the MR because MR, as I said again and again, is for 1 formula unit. Be very careful. We always start with MR first. MR is for 1 formula unit. So there are 2 carbons. So I can talk about 12 times 2 plus 4 times 1. That will give me 28 for 1 formula unit. I don't need to care about oxygen. None of the question asked me about oxygen. Carbon dioxide I already worked out. Remember, it's for 1 formula unit because this is my label for MR. So this is 1 formula unit because there is MR for 1 unit. And then for water is H2O. If you think about the MR of H2O, there's going to be 2 times 1 plus 16 times 1, that's just 18. Now, of course, this equation is not just one. This is what we call reacting mass. Reacting mass is based on the number in front. So there's 1 of it, and the MR is 28, so it's 28 gram. Here there's 44 for 1 unit of CO2, but there are 2 of it. So 44 times 2, because there are 2 CO2. So reacting masses depends on the number in front. So 44 times 2 give me 88 gram. And then 2 times water. So there's 2 times 18, give me 36. That is what I use for my calculation because there's reacting mass. So as you can see, I already done it. 28 gram of ethene will react to form 88 gram of carbon dioxide, and it will react to give me 36 gram of water. This question comes down to what do you understand by MR for 1 formula unit? What do you understand by balance equation depending on the number in front of it? Next up is a tricky question because they want carbon dioxide, they want ethene, and the number is not as nice anymore. But we are going to do the exact same thing. 1 of C2H4 will give me 2 of CO2. From the balance equation, 1 of it give me 2 of CO2. So from my reacting mass, 28 gram of C2H4 give me not 44, but I have 44 times 2 because I have 2 of that CO2, so 88 gram. I want to use 0.7 gram of ethene. This is C2H4. So this is my unknown. What is my mass of carbon dioxide? I hope by now you should be able to do your cross multiply thing. 28x equal to 88 times 0.7. So, show your working. It's really bad when someone submitted their work with only answers because, well, one thing is, how do you know the work is honest? Oh, well, I mean, in the real thing, the truth will always come out. So just be careful about what you're doing here right now. In a molecule of ethene, so as you know, C2H4 looks like this because this is not dot and cross. This is just showing the covalent bond. The carbon has 1, 2, 3, and 4 covalent bonds. So this is a double covalent bond. Double covalent bond means there are 4 electrons involved. So cross, 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 cross dot, cross dot, cross dot, cross dot. Dot is for the hydrogen. This is a normal covalent bond. This is between carbon and carbon. This is between carbon and carbon. This is a pair which give you 1 covalent bond. This is another pair which give you another covalent bond. Okay. So 3 more minutes. Let me see why I can finish it off. So this one, straight from your syllabus and your notes. So as you can see, they do ask you things like this. It is stated in the syllabus. You must know how to define AR. So go on and look it up. Calcium hydroxide. So you have calcium 2 plus and OH minus, 2 and 1. This is your valency from your crisscross formula. So there is 1 and 2. So that means calcium 2 plus, OH minus, OH minus. That's why the formula there is going to be 1 calcium and 2 of that OH minus. Again, this pH is greater than 7 because it's a base or alkaline. As you know, hydroxide ion is the one responsible for the pH greater than 7. This is MR for calcium hydroxide. What does the bracket mean? The bracket means 2 times OH minus because it comes to your crisscross formula. If you look carefully at the crisscross formula, there is 1 of that and there is 2 of that. So that means 2 of oxygen and also 2 of hydrogen. So do not read that incorrectly. So there's 40 for calcium, and then I have 2 times whatever is in the bracket. I have 1 oxygen, 1 times 16, and I have 1 hydrogen. So if I were you, I would do this in the bracket first. 16 plus 1 is 17, and then times 2 because I have 2 hydroxide plus 40, I get 74. Okay. So yeah, what do I have? So this is all 1, 2, 1, 1, and they have water and they have hydrogen. Remember, MR is for 1 unit. Be very careful there. MR is for 1 unit. So we're looking at 40 because there's AR for that. There's 18 because for 1 of the water, only 1 water, only MR because MR is for 1 unit of water. And then you have MR of calcium hydroxide, which is 74. Now I want to talk about reacting mass. This is the most important thing. This is 40, this is 18 times 2 because there are 2 in front, there's 36, and there's 74. So this is gram, gram, and gram. Hope you'll be able to see that 40 gram of this will react with 36 gram of water and give you 74 gram of that. And you have calcium with water. So 40 gram of it and 36 gram of it, 2 gram of it will give you X. So 40X equal to 36 times 2. So X equal to 36 times 2 divided by 40. And you should be able to get 1.8 as your answer. All right. So that's it really. So it's now 9:09. So I better stop this and I'll stop recording. And you guys can feel